So in the first lecture, it will show our schedule about the topics and the tutorial sessions and also the midterm exams. And actually, we need to make some slightly modification to catch the schedules as we designed previously. Because in the first half of this term, we spent some time to introduce the midterm solutions. There will be some actual examples we included, and the schedule is delayed a little bit. So for the rest of the term, especially for the midterm 2, which will be the most important part you want to know, we will, instead of taking the midterm 2 on November 15th, we will probably postpone this one to week 11. That will be around November 22nd. So this is one big change about the schedule of the midterm, and with that the contents for the tutorial session will also be modified a little bit. I will give you a very detailed update about what we're going to do for all the rest of the tutorial sessions. And another thing is about the lab experiment. I have updated the deadlines for different lab reports, and of course, we anticipate that there might be some interruptions about the lab experiment due to the weather conditions. If that happens, the TA and I will keep on communicating with each other and try to adjust the deadline accordingly. But for now, you can follow the announcement on Avenue to Learn for the deadline to submit your lab report. So this would be something I would like you to know. And again, as what I just explained, we will update everything on Avenue to Learn. So do you have any questions so far? If you don't have any questions, I will start the lecture today. Okay, that's good. So with that, I will start our lecture today, and let me see whether there's any question. So for the midterm, yeah, the midterm will be on November 22nd. It will still be during the tutorial time. So the setting will be exactly the same to the first midterm, and more details will be released on Avenue to Learn. So just follow the announcement there. Okay, so with that, I will, okay. Is it possible to extend the deadline of homework 5? For the deadline of homework 5, I can actually extend this one to Sunday, but there's another deadline for the homework 6. The homework 6, I really wish will be the deadline will be in the next Friday. If you don't think there's any conflict about or if you don't think it's too intense for you to work on homework 5 and homework 6, that should be fine for me. Because I really want to deliver the solutions of homework 5 and homework 6 to you as early as possible, so that you have some time to go through those solutions and prepare for your midterm exam. So if you agree with that, I'm going to extend the deadline for homework 5 to accommodate any other exams that we have. Okay. So that's the things. Okay, if you don't homework, I'm not quite sure what kind of homework we are talking about. If you are talking about homework 5, homework 4, that will be due this Friday. If you are talking about homework 5, that will be due next Friday. I'm not quite sure which one you are talking about. I can do the extension for, okay. If I'm talking about homework 4, that's fine. I can extend this one to this Sunday so that you have some time to work on over the weekend. I guess that will be more flexible for us. Okay. So we will extend the deadline for homework 4, not the homework 5. Okay. So if you don't have any additional questions, I will start lecture today. Okay. So let me just share my screen. So last week we go through the fundamental knowledge about the traverse, where we're going to measure the distance and directions of a set of the lines and try to identify the boundaries of the length or identify a set of the segments in the ground. We have introduced the method of utilizing the deflection angle to do the traverse. Also, there will be some introductions about how to calculate the angles of the or directions of the line based on the deflection angle and the azimuths of those lines. And suppose that we have collected all the informations of all the lines. Then the next thing we need to think about is how we're going to correct the errors during the experiment. This table shows the summarize the information that you're going to observe during the experiment, during the traverse. You observe the azimuths of all the lines that you measured. You know the true azimuths of the start line and the true azimuths of the ended line, and you actually measured the deflection angle for all the turning points. And with that, we have to know how to do the computation. So in this table, we stopped at last time. We stopped at the observed part and the calculated part. So for start from that point, we're going to introduce how we're going to do the calculation, how we can find out the errors, how we do the corrections, and find out the adjusted azimuths, and also convert the azimuths to bearing. The last part would be relatively easy because we have already introduced the formulas for you to do the conversions between azimuth and bearing. So for the deflection angle, for the deflection angle traverse, we have provided with the azimuths for, if we are talking about the previous example, we are provided with the azimuths of the first line, SR. And in that example, we get the SR as 350 degrees, 30 minutes. By the way, the line should be like this one. This is the closed traverse with the deflection angle. This should be the general sketch of the boundary of those lines. And we are provided with the azimuth of the line SR, so that is 350 degree, 30 minutes, 0 seconds. We also know the azimuth of the end line, which would be the true azimuth of that line. So it's 104 degree, 42 minutes, 30 seconds. And we can find out the deflection angle. We know all the deflection angle. And of course, we know the angle to the left or to the right. So what we do is like, we know the azimuth of the line SR. What we want to do is like, we need to find out the azimuth of the line R to T, which would be the line next to the SR. Based on the equation that we showed previously, the deflection angle at R is angle to the right, so it's actually alpha 1 R, and this will give us the way for us to calculate the azimuth of the line R to T as the azimuth of SR. If it's to the right, then we will plus the angle, so it's alpha 1. And for this case, we know that SR, the azimuth of SR is 350 degrees, 30 minutes, 0 seconds. And alpha 1 is 140 degree, 10 minutes, 0 seconds. This comes from the observation. So those would be the observation from the traverse surveying. And you know all the deflection angles. And obviously, this summation is higher than 360 degree. In reality, the azimuth cannot be higher than 360 degrees. So what we do is like we will just minus 360 degree to make sure that the value is between 0 and 360 degree. So with that, you will get the value as 130 degree, 40 minutes, and 0 seconds. So this is the way for you to find out the azimuth of R to T. And similarly, you can find out the azimuth of the other lines, T to U. This is a sequential calculation. For the calculation, you find out the value is R to T is 57 degree, 20 minutes, 0 seconds. And here you have to know that for those calculations, if you find any azimuth is higher than 360 degree, you need to make sure that you're gonna minus 360 degree. If you find this one is smaller than 0, is possible, is the azimuth you calculate is smaller than 0, then you need to use this one to plus 360 degree to make sure that eventually all the azimuths you calculated is between 0 and 360 degree. So this is the criterion for you to find out the azimuth of each line. So based on this calculation, you can find out azimuth of T to U and U to V, 106 degree, 50 minutes, 0 seconds, and V to M, it's 157 degree, 10 minutes, 0 seconds, and M to N, this is the estimated value. It's 104 degree, 45 minutes, 0 seconds. So this one is actually different from the true value. The true value is 104 degree, 42 minutes, 30 seconds. So with that, you can find out the error between the estimated value and the true value. So that's the second part, the error. The error will be the estimated value, 104 degree, 45 minutes, 0 seconds minus the true value, 104 degree, 42 minutes, 30 seconds. So what do we get that the error is 2 degree, 2 minutes, 30 seconds. So this is the error we obtained. And now we need to do the correction. So this is all the azimuths we estimated, and we observed and estimated, and we find out the error is 2 minutes 30 seconds, which means that the correction should be minus the error. So that is minus 2 minutes 30 seconds. And you know that we actually measured 5 different deflection angles. So on average, each deflection angle will contribute to so the data would be minus 2 minutes 30 seconds divided by 2 divided by 5. So we have 5 deflection angle, and each one will contribute to minus 30 seconds. So to get this value, you need to convert everything to the seconds and then do the calculation. So with that, we can then go to check the correction. So for the correction, we're going to start with the first line. For the first one, the line S to R, which is the true, which we will have the true azimuth. So the correction is 0. So we say that it's a minus 0 seconds. So there's no change. And for the second one, you will add one of delta t. So it's a minus 30 seconds. And for the third one, you add another delta, so it's a minus 60 seconds. This one is just minus 1 minute. And for the third one, similarly, you add another delta, so it's a minus 1 minute 30 seconds. Similarly, you have the first one minus 2 minutes, and last one is minus 2 minutes 30 seconds. And then you can find out the adjusted azimuth. The adjusted azimuth would be the azimuth, the estimated azimuth plus the correction. So the phrase there for SR is the true value. It's 350 degree, 30 minutes, 0 seconds. And for the second one, the estimated value plus the correction. So what you get is 130 degree, 39 minutes, 30 seconds, and similarly get the third one, 57 degree, 90 minutes, 0 seconds, 106 degree, 48 minutes, 30 seconds, 157 degree, 8 minutes, 0 seconds, and eventually find out the last one for the for the line MN. It's 104 degree, 42 minutes, 30 seconds. So with this correction, you can make sure that the azimuth of the first line and azimuth of the last line will be the same to the true value. So this is our purpose to do the correction. And with that, we can get the estimated value of each line in between. So this is the value you want to, this column is the value you want to release for the directions of all the lines during the traverse survey. So that's for the closed traverse. We also have another method which is called the closed loop traverse. So with that, we're gonna measure the loop. So for example, we can consider a closed loop. Say that this is the line AB at the polygon of A, B, C, D, and E. We are provided with the for the closed loop, we just need to know the true azimuth of one side. So we say that we are provided with the azimuth of the line AB. The line AB is given, and then we do the deflection angle traverse for all the points for the point B, C, D, E, and even at point A. With that, we can then find out the azimuth of each line and do the correction. Also, we want to make sure that the error, with the adjusted azimuth, the error should fall to 0. So generally for this kind of traverse survey, you will observe the you have true azimuth of the line A to B. From point A to B, the angle, say that the angle is 228 degree, 0 minutes and 0 seconds. And you also measure the deflection angle at the point B, which is 113 degree, 38 minutes and 30 seconds to the left. And similarly, you do the observations, the measurement about the line. You can try to calculate the azimuth of the line B to C based on your calculation, which would just be the this value, the azimuth minus the deflection angle at point B, because this one is to the left. So what you get is like the for the azimuth of B to C, it's 114 degree, 21 minutes, and 30 seconds. You're gonna measure the deflection angle at the point C. So the measured value. Just a moment. The measured value. Just a moment. Let me try to adjust the color a little bit. Okay. So the measured value is something wrong with my pen. Just a moment. Just a moment. Let me try to exit and return it back. Okay. So the measured deflection angle is at point C. It's at 98 degree, 15 minutes, 00 seconds to the left. And then you can find out the azimuth of the line C to D. So this is the azimuth B to C, and this is the azimuth C to D. You can calculate the value as B to C, the azimuth of B to C minus the deflection angle, because the angle to the left. So what you get is a 16 degree, 6 minutes, and 30 seconds. And then you can you also measure the deflection angle at point D, which is 88 degree, 19 minutes, and 0 seconds to the left. So with that, you get the azimuth of D to E as the at this azimuth of C to D minus the deflection angle. You have to know that if you're using this one minus this value, the value will be less than 0. So in that sense, you have to add a 360 degree. So what you get is 287 degree, 47 minutes, 30 seconds. And then you're going to measure the deflection angle at a point E. So say that the value is 117 degree, 42 minutes, 30 seconds to the left. And you can find out the azimuth of E to A as this one minus the deflection angle to the left, which is 170 degree, 5 minutes, 0 seconds. And then you're going to measure the deflection angle at point A. The deflection angle at point A will be 57 degree, 55 minutes, and 0 seconds to the right. And with that, you can calculate. So the azimuth of A to B, that is 228 degree, 0 minutes, 0 seconds. Here you can see that these two values These two values are exactly the same. This is the estimated value, and this is the true value. So if they are exactly the same, means that your measurement is accurate, it's perfect. So the error in this case will be 0. So you don't need to make any adjustment because you don't have any error in this case. But if you observed any errors in this survey, then you need to continue to do the adjustment, similar to what we did in the previous page. So this is actually what we did, and we can find out the azimuth, and we find that there's no error. The error is 0, 0 degrees, 0 minutes, 0 seconds. So we don't need to do any adjustment. And if we want to find out the bearing, you can convert the azimuth to bearing directly. If you prefer to present the result with the bearing. So this is about the closed loop traverse. In this case, we don't have any error, so that's perfect. But if in the future you have any errors, then you need to do the correction. And for the closed loop traverse, we can also do another. We can also do the traverse with the interior angles, which would be more straightforward. For example, here I'm just considering just a moment. Let's just considering a line with the a polygon as 6-side. I think it's a 6-side polygon, 1, 2, 3, 4, 5, 6, and we know the initial deflection, initial directions of the line Q to 1, which is does not belong to the polygon. In the experiment, we will find out we're going to measure the azimuth of the line 1 to Q, which is a given, and then we also measure the angle of Q12. So this would be the which would be this angle. And we also going to measure the deflection angle alpha 1, alpha 2, alpha 3, the interior angle alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, and alpha 6. And with that, we're going to use all this information to find the azimuth of all the sides. And this is the way for us to do the interior to do the traverse with the interior angle. And so let's just see one example about the previous traverse with the interior angle. So we know the azimuth of the line from 1 to Q. We also know the angle of Q. Say that we know the azimuth of 1 to Q. We also know the angle of Q1 to 2. And then we can find out the azimuth. We can find out the azimuth of 1 to 2. For this example, the azimuth of 1 to 2, which would be the this line, will be the azimuth of 1 to Q plus the angle Q12. So what we observe is A1 to Q plus the angle of Q12. And this is about the azimuth of 1 to 2. In this example, we can find out the value is 106 degrees, 20 minutes, and 0 seconds. With the traverse for based on the interior angle, we also need to find out the backward azimuth. So if you know the azimuth of 1 to 2, what you need to do is you need to find out the azimuth of 2 to 1. For this specific case, the azimuth of 2 to 1 actually equals to azimuth of 1 to 2 plus 180 degree. But this is just for this specific case. It could be it could be the azimuth of 1 to 2 plus 180 degree, or it could be azimuth of 1 to 2 minus 180 degree, depending on the situations, depending on the values of the azimuth. And this is for the first step. And in the next step, you also need to find out the azimuth of the line 2 to 3. And for this specific example, the azimuth of 2 to 3 equals to the azimuth of 2 to 1 plus alpha 2. And of course, you also need to find out the backward azimuth of 3 to 2. And it could plus or minus 180 degree for the azimuth of 2 to 3 based on the value calculated. And this is the side of the 2 to 3, and you're gonna go to the azimuth of 3 to 4 and get a 4 to 3, and the fourth step, the fifth step, and the sixth step to find out the azimuth of all the lines. So this is what we do about the calculation. For this case, we can find out the azimuth, or for this specific example, we find out the azimuth of 2 to 3 at 57 degree 55 minutes, and you can find out the azimuth of 3 to 2 by plus 180 degree, which would be 237 degree 55 minutes. And then you can use the interior angle to find out the azimuth of 3 to 4, and the backward azimuth of 4 to 3. This is 335 degree minus 180 degree, where you're going to get this value. And similarly, you can find out the value, the azimuth of 4 to 5 and 5 to 4, and 5 to 6 and 6 to 5, 6 to 1, and 1 to 6. And eventually you will get the value of 1 to 2, which would be the estimated value. And you also have the true value, which would be the one you find at the beginning from the true azimuth of 1 to Q and the true angle of Q12. You can find out the error between the estimated azimuth of 1 to 2 and the true azimuth of 1 to 2, which will give you the error, the closure error, as the difference of these two values. In that case, that is 3 minutes for this example. And so in that sense, the correction will be minus 3 minutes. So it's always the negative value of the error. And for this case, you need to put the error, the corrections for the for each azimuth you estimated. For 1 to 2, definitely it's 0 second, because that will be the true value. You can find out the azimuth, the correction for 2 to 3 as 30 seconds. Because here we have 6 angles measured, so the correction delta for each one is 6 minutes. 3 minutes divided by 6, that will be 30 seconds. So for the first one, 2 to 3, it's minus 30 seconds. 3 to 4 is minus 1 minute, and then you get a minus 1 minute 30 seconds, minus 2 minutes, minus 2 minutes 30 seconds, and minus 3 minutes. With that, you can find out the adjusted azimuth for all the sides: 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 6 to 1, and then back to the correct value of 1 to 2. So this is the way for us to do the traverse with the interior angle. This is one method for us to do it. And we also can do the correction. We also have another method to do the correction. We know that for the n-side polygon, so we know that for the n-side polygon, if you summarize all the interior angles, the value that the total value you will observe would be n-2 times 180 degree, right? For this specific example, we have n equal to 6, so which will give you the total value should be 704 times 180 degree. That will be 720 degree. So this is the total degree of all the interior angles for the 6-side polygon, and we know we actually measured, for this example, we measured all the interior angles. If you summarize them together, they should equal to 740 degree. But for this example, what we observe is that we summarize them together, and we find that their value is 720 degree, 3 minutes, 0 seconds. Clearly it's different from the theoretical value. So we can find out the error. This is the closure error. Is 3 minutes. So we will have the correction. We'll have the correction equal to -3 minutes. And then delta equal to -3 minutes divided by 6 is -30 seconds. And this indicates that we need to do the correction for each interior angle. The correction for the interior angle is a little bit different from the azimuth. So this is the correction for the interior angle. So for the interior angle, for the correction, you just need to apply delta to each interior angle. So in this case, that will be -30 seconds. So with that, you can find out the adjusted angle, which here is the interior angle. The interior angle. And if we do the summation about all those adjusted interior angles, it should be equal to 720 degree. That will be the theoretical value. And obviously, this kind of adjustment will make sure that you have all the correct interior angles. And then you can go back to the previous page, apply the adjusted interior angles. Apply all the adjusted interior angles, changing this one to the interior angles, to the adjusted interior angles, and then you can find out using the same process, you can find out the azimuth of all the lines. And with that, you don't need to think about, the corrections with the azimuth. So that's the second method for you to do the correction with respect to the interior angle directly. So this is about the traverse with the interior angle. We have 2 methods to do the correction. The next one that we're going to show is about the traverse with the angle to the right. So here, instead of using the deflection angle or the interior angle, we can use the measure the angle to the right to find out the directions of all the lines in between. For example, let's consider one example. So let's consider one example, Z, Y, A, R, S, T, and U. We are given the azimuth of the line Y to Z and the azimuth of the line T to U. So we are given the true azimuth of the initial line Y to Z and the end line T to U. Also, we're going to measure the angle to the right for all the turning points. So we have alpha 1, alpha 2 at the point A, alpha 3 at the point R, alpha 4 and alpha phi. So this is the measured value. And then we can use this information to find the azimuth of the other lines. So this is about the traverse with the angle to the right. Instead of measuring deflection angle, we measure the angle to the right. Also, you have to recall the definitions of the angle to the right. The angle to the right will always start from the initial line to the end line, and the angle is always clockwise. So there's one advantage for us to do the angle to the right. Actually, for most of the situations, if you have the angle to the right, it should follow one equation. So that is the azimuth of y to z plus the summation of all the angles to the right minus m minus 1 times 180 degree minus the azimuth of the last line t to u. This value should be 0, and here n is the number of the angle to the right you measured. The angle to the right you measured during the experiment. So this is the traverse by the angle to the right, and let's quickly go through one example to see how the one is how we're going to use this one and how we do the correction. So with this one, we are given the azimuth of the initial line y to z, and we also provided with the terminated line t to u, and we measured the angle to the right. So this is the angle to the right for alpha 1 at the point y, and this is the angle to the right of at point A, and similarly have the angle to the right alpha 3, alpha 4, and alpha 5. And you can actually calculate the azimuth of each line. So for example, for the azimuth of line A to Y, that will be the azimuth of Y to Z plus alpha 1, and you find that the value is 100. It's more than 160 degree, 360 degree. You need to do the modification, and also remember that this is the azimuth you measured for the Y to A. You need to convert this one to A to Y and do this adjustment minus 180 degree. So this is the way for you to find out the azimuth of all the lines A to Y, R to A, S to R, T to S, and then eventually T to U. As you know the true value of T to U, you can find out the error. So the closure error in this case it's 25 seconds, and to do the correction, delta would be 25 seconds minus 5. That would be 5 seconds. So you need to apply the correction for each. So in this case the closure error is minus 25 degree. Sorry, I guess there will be something wrong about the calculation. So the error is minus 25 seconds, and then the correction should be 25 seconds. And what you will observe about the delta would be 5 seconds. So you need to plus 0 seconds for the first one, Y to Z, and then plus 5 seconds, plus 10 seconds for R to A, 15 seconds for S to R, 20 seconds for T to S, and 25 seconds for the T to U. And with that, you can find out the correct azimuth of all the line between y to z and t to u. So the calculation will be exactly the same to what we introduced previously. The only issue is about how you can gonna convert the angle to the right to how you're gonna use angle to the right to calculate the azimuth between two lines. So we also have another more straightforward method, which is called the azimuth traverse. With that, we're gonna measure the azimuth of each line directly. So this one shows one example about the azimuth traverse. For example, at point 1, you're gonna measure the azimuth of at point 1. You're gonna measure the azimuth of 1 to 2, and also the azimuth of 1 to 5. So you're gonna measure these two lines, these two directions, and then you can actually calculate the interior angle alpha 1. In this case, the interior angle would be the azimuth of 1 to 2 minus the azimuth of 1 to 5. For this specific example, 1 to 2 is a 350 degree, 30 seconds, and 2 to 1 is a 1 to 5 is a 270 degree, 28 minutes. So you get the result as 80 degree, 2 minutes. So this is for the point 1, and for the point 2, you measure the azimuth of 2 to 3 and the azimuth of 2 to 1, and then you can find out the angle, interior angle of alpha 2. And similarly, you can find out the value for all the other points of this polygon. And eventually, you're gonna need to double check the error. So ideally, it should satisfy the condition for the summation of all the interior angles. They should be equal to m minus 2 times 180 degree. So this is the way for you to do the correction. And this is actually one notebook for us to do the azimuth traverse. We're gonna find out the correction for each interior angle, and then the error of the interior angle, or the summation for the interior angle. In this case, you find the error is 1 minute. Then you need to apply the correction for each interior angle, and then convert them back to the azimuth as what we do for the previous method, the traverse with the interior angle. And this is about the azimuth, the azimuth traverse. And we have another method which is called the compass traverse. So actually all these methods will be very similar to each other. The only difference is the way for you to show or to measure the directions of the line. So for the compass traverse, instead of using the azimuth or the interior angle, you're gonna use the bearing to measure the direction of each side, and you can convert the bearing to azimuth. Then the measurement will be exactly the same to the azimuth traverse. You can also use the bearing to calculate the interior angle. Then in that sense, the compass traverse will be exactly the same to the traverse method with the interior angle. So the key point here is you need to convert bearing to azimuth or to interior angle, or you can go to convert them to deflection angle or to angle to the right. So do this conversion, and then the procedures will be exactly the same to what we described previously. I think that will be all. We have run out of time. That will be all today. We only have one additional method going to introduce about the stadium traverse, and I will save this one for the next lecture. So before I leave the meeting, do you have any questions about the notes? Any questions? Well, I know you asked some questions about homework 4, question 7. I cannot recall which question it is. Let me quickly bring out the questions first. Oh, by the way, I have the if you have any questions about the homework assignment or anything else, you can actually stop by the office hour, which will be the 12:30 to 1:30 on each Wednesday, and there's a meeting in the office in the office hour channel. So your questions are for how do we know if the set is acceptable? So you have to make sure that the arrow to check whether the result is acceptable. You have to make sure that the arrow is smaller than the so the list count is 30 seconds, right? So you have to make sure that the arrow is less than 30 seconds. So the value you observe from the direct measurement and the value you estimated is less than 30 seconds. This is the related to the precision or resolution of the instrument. Okay. So any other questions? If no, I will close the meeting today and I will see you tomorrow. Okay, good. Again, thank you very much for your time, and I will see you tomorrow. And also, please keep your eye on the Avenue to Learn about any announcement related to this class and the update of the course schedule and the the second midterm exam. Okay, thank you very much, and I will close the meeting and see you tomorrow.